Everyone, I am Sainath. Today we are going to discuss the topic about constraint satisfaction problem. Okay, so in this chapter, we are mainly focus like how to solve the problem by using AI agent, right? So like here to solve the problem where we have to assign certain values to the variable. Okay, so by assigning the values to the variable, we have to follow certain constraint. Okay, certain rules we have to follow to assign the values to the variable. For example, like let's take one game, Sudoku game. Okay, so in this game, like what is the rule behind that? There is a set of grid is there, so we have to assign the value in the grid by following certain rules. Like there is no same row and same column have that same value. That means like all the rows and column grid is to be a distinct value, right? So this is the main example for this chapter. Okay, the constraint satisfaction problem. So like whenever we are speaking about the constraint satisfaction problem, we have to mainly focus on three things. One is variable, second one is domain, and third one is to be constraint. Okay, like what is variable? Variable is nothing but like the variable is mainly used to assign the certain values to it. Okay, for example, in Sudoku, each and every grid act as a variable. Okay, next we are coming to the topic of that domain. Okay, what is domain here? Like whenever we have to speaking domain. Okay, so there is what is the certain range of possibilities to assign the value to that variable. What is domain means what are the possibilities or what are the possible values we can able to assign the variable. Okay, for example, in Sudoku, let's take in Sudoku same example. So we can able to assign the value from 1 to 9. Okay, by non-repeating. Okay, next we are coming to the topic of constraint. Okay, like whenever we have to speak in the constraint means what is generally constraint? Constraint is nothing but it is set of rules. Okay, so let's take same example as Sudoku. Okay, in Sudoku, like what are the constraint is there? Like each row and each column there will be group of grid, so each and every grid has unique value from 1 to 9. Okay, these are the constraint in Sudoku game. Okay, so these are the main three components when we are speaking about constraint satisfaction problem. Okay, one is variable, second one is domain, third one is to be constraint, right? So next we have to discuss about like how to solve that constraint satisfaction problem. Like what are the process behind it? Like whenever we are trying to make one AI agent. Okay, so how we can what are the process or what are the algorithm we can incorporate to that our agent, then it can play Sudoku game like as much as like it will faster to win the game. Okay, so firstly we are speaking about like backtracking search. So what this backtracking search will do? First, in the backtracking search, what it do means, firstly it will assign certain value to the particular grid. Okay, it will assign like some randomly it will assign one values to the grid. Okay, so then it will check the constraint whether this value is obey that constraint or not. If it obeys that constraint, then that value has been acceptable. Suppose that value is, suppose like let's take in Sudoku game. In Sudoku game, suppose like we are inserting one value, that value is already present in that same row or same column. This it not obeys that rule, na, it not obey constraint. So other time what it will do means it will simply remove that value. Instead of that value, it will try to insert that new value. Okay, so this is the process behind the backtracking search. Nothing, backtrack is nothing but firstly it will assign certain value randomly. Next it will check like whether this value is follow or obey our constraint or not. If it obeys, then it will accept that value. If it not obeys, then it will remove that value. It will remove that value. Instead of that value, it will assign new value. Okay, that is the main concept behind the backtracking search. Next we will come into the topic of constraint propagation. So in this constraint propagation, what it will do means it will reduce that some randomness. You know why? So firstly, like before, suppose it will assign one value. Okay, next like in next time it will assign next value means firstly it will check like whether like we have to assign that value, it is equal to any other value like in that same row or not. Okay, like it will narrow down our randomness. Okay, according to the constraint, it will assign the value. So because of that, our randomness will decrease. Okay, like in this constant propagation is nothing but like previously what we discussed, it will assign randomly, then it will check the constraint. Okay, here in this constant propagation, before we insert before we assign a particular value in the grid, firstly it will check the constraint whether this value is applicable or not. Like if it applicable only, then it will insert. Okay, otherwise it will not insert. Like here there will be insert and deletion process not happen, like as we discussed earlier. Okay, so the so this process is known as, is this process generally known as propagation. Okay, so this is the full description about constant propagation. Next we will come into the topic of heuristic. So whenever we are talking into the process of heuristic, what it will do means, uh, like in this process it always think the clever ways. Okay, for example, like whenever we assign the certain value to the one grid. Okay, so it will check what, like it will take some range of values which is not we assigned as earlier. Okay, suppose like for example in Sudoku game, for example 1 to 9 is our range. First, like in this heuristic, firstly it will assign one for the first grid. Okay, next it will make arrangement of, so it will make certain range of arrangement. Okay, we have inserted one. Now in our hand from 2 to 9 is there. Next time it will set into 2. Okay, next there will be, our range will be changed from 3 to 9. Like this heuristic search will work. Okay, next these are the full description about heuristic search. Next we will come into the topic of local search. What is local search will do, you know, like in this, the first value to assign to the first grid, it is random value. Okay, so after that, if we try to assign the value to the next grid or further grid, what it will do means, it will make slight change to the previous grid. For example, let's say like I will assign the first grid as like 7. Okay, next time it will assign as 8. In next grid at it will assign as 9. In next time it will assign it like some 2 3 like that. It is a slight change, it will do like that. This is the process of local search. So it will make some, like by using the local search, our AI agent will work as faster and quicker to make a quick decision, like which value I have to assign to that variable or to that grid. This is the full description about constraint satisfaction problem. Okay, next we will come into the topic of what are the real world application we are using this constraint satisfaction problem, or like how our AI agent, what are the ways like our AI agent will work in the real world, like this constraint satisfaction problem. First one is, as we discussed earlier, like Sudoku game. What in Sudoku game will do, like we have to assign the value. There is no same row and same column in each grid as same value. That is a constraint here, right? And also like so we have to, there is certain range is there from 1 to 9, like we have to assign certain value to that grid. So this is some real world application. Next, in another real world application is to be map coloring. This is also like one of the important application. What it will do means, what is the constraint in this map, what is the constraint behind this in map coloring, you know, there will be no adjacent color has to be same. For example, I have red color here, no adjacent color have the same color as red. These are the constraint here. Okay, so in this they are giving the certain range of colors to you, so to the agent. So whatever agent will do, it will do that, like all the steps which has discussed earlier, like how CSP work, constraint satisfaction problem work. Like for example, like that backtracking process, and as a constraint propagation process, and local search and heuristic. Yeah, it will simply uses like those kind of things, and it will make the decision accordingly. Suppose like first time it will assign red means the next time it will try to assign blue. In next time blue means next time it will be green. So similarly it will assign like that. So these are the one best and good example for constraint satisfaction problem in real world. Okay, these are the full description and full summary of this chapter of constraint satisfaction problem. Like what are the things we have discussed as much as this chapter? Firstly, like we have discussed about like what is this chapter tells, and how constraint satisfaction problem works. So what are the process behind that? So how our AI agent will make a decision accordingly, and that what are the components when you are speaking about constraint satisfaction problem. For example, that variables, domains, and constraint we have discussed as much as for. So these are the full description, full summary of this chapter. Okay, thank you guys. Bye bye.